So as we move to the back of your notes worksheet today, we're going to be taking a look at the problem from the 2005 AP exam where we're going to be working with this type of matched pairs t-interval. For right now, you can bypass the information at the top of the page. So let's read this problem over. It says a researcher believes that treating seeds with certain additives before planting can enhance the growth of plants. An experiment to investigate this is conducted in a greenhouse. From a large number of Roma tomato seeds, 24 seeds are randomly chosen and 2 are assigned to each of the 12 containers. One of the 2 seeds is randomly selected and treated with the additive. The other seed serves as a control. Both seeds are then planted in the same container. The growth in centimeters of each of the 24 plants is measured after 30 days. These data were used to generate the partial computer output shown below. Graphical displays indicate that the assumption of normality is not unreasonable. Construct a confidence interval for the mean difference in growth in centimeters of the plants from the untreated and treated seeds. Be sure to interpret this interval. So what we have are 24 seeds, and we're splitting them into 12 groups of 2 each. So we were kind of pairing up these seeds. So that kind of is an indication you're working with a matched pairs design. The other thing you'll see in the instructions for A is it talks about the mean difference in growth. So anytime it talks about a mean difference, a mean increase, or a mean decrease, that's also probably a good indication you're working with a matched pairs design. So in step 1 of our problem, this is where we talk about PPP, procedure, parameter, and population. So our procedure is a matched pairs t-interval. Our parameter deals with something about the mean. You might remember on the front side of the worksheet we said that the parameter is going to be in the form mu diff, the mean difference, or the mean increase, or the mean decrease. So as we look at our reading here, you'll notice that it doesn't talk about means a whole lot, but it does mention it in the instructions. Construct a confidence interval for the mean difference in growth. So that's what we're working with here. Mu diff is the mean difference in growth. And the third P stands for the population. Now in this problem, think of what N is. N in this problem is 12. There's 12 differences. So you've got to think we have 12 what? If you want to say something like 12 pairs of seeds, I think that's fine. If you want to talk about the idea that we're comparing the mean difference of growth in the plants from the 12 containers, that's fine. But think of 12 as your sample size. So we have 12 what? 12 sets of plants, 12 containers. So if that's your sample, the population is going to be all sets of plants or all containers. And I think it makes sense because when you're talking about a difference, you're getting at the idea of subtracting things. So we're subtracting values from 2 pairs of plants, for example. That's your first step. Second step, check conditions. The first condition deals with random samples. And we're looking for the term random, and random appears a couple places. It talks about seeds are randomly chosen, and one of 2 seeds is randomly selected and treated with the additive. I like including both these pieces of information really to avoid the bias. I think we really want to be concerned with making sure that the seeds are randomly selected and treated with the additive. So picking which seed is randomly selected. I think that's the key part, but I will note both of those things because I think it's important to kind of address both of those issues. And the first part kind of deals with a random sample. The 24 seeds are randomly chosen. So I think it's fine to say a random sample was chosen. But I think it's also good to talk about how the seeds were kind of randomly assigned into groups. So I'm just going to plagiarize this sentence that talks about one of the 2 seeds is randomly selected. So we have a couple layers of randomness here. That's kind of unusual. Most questions kind of just talk about like random assignment of seeds to containers. So we addressed both of them here, so we're going to be safe. The second condition, we're going to check to see if we have normal information. If not, we'll see if we have a large sample size. If not, we'll go to the graphing step. Unfortunately, if you read the last sentence, it says that graphical displays indicate that the assumption of normality is not unreasonable. It's basically a complicated way of saying they've done some graphs. It looks like we can assume it's not unreasonable. It is reasonable to say that the graphs are normal. Instead of putting this into our own words, I think it's just great to plagiarize this because it's less thinking we have to do and it's easy just to kind of copy this down. That's okay to do that here. It says it's okay that this is normal, so we're just going to copy down this sentence. So there's 2 conditions we have to check. We're kind of looking for keywords like random and normal. And if we have those things, it makes this step a lot easier. The other issue is that we don't have a large sample size. We only have 12 sets of points, and we don't have any data we could even graph to kind of address condition 2C. So it's good that it says this information is normal. Let's move on to actually constructing our confidence interval in step 3. So X bar diff is the mean difference. We have a table here that talks about a mean difference of being negative 2.015. That's what we're going to use for the mean difference. In some problems, unlike this one, for example, on the front side of the worksheet, if you had this list of pre-test and post-test scores, what we would do is we would put these numbers in your calculator, the 6, 5, 2, and 14, do one var stats, and your X bar diff is going to be the mean of these values here. So you could either add all 4 of these numbers, divide by 4, or put them in a list in your calculator. And whatever the calculator says X bar is, that's what you'd use for X bar diff. Then we include the plus or minus. Now we need to figure out what T star is equal to. For this, we're going to go to your table B in your green packet. Remember that in our problem, it asks you to just calculate a confidence interval. It doesn't say what percent to use, so if it doesn't give you a percent to use, usually we use the default of 95%. Degrees of freedom. Because we have 12 pairs of numbers, your n in this problem is going to be 12. So when we're calculating the degrees of freedom, and I'd like to write this down on my paper, the degrees of freedom is going to equal n minus 1, or 12 minus 1, which equals 11. So we're going to look up here on your table 95% confidence and 11 degrees of freedom. And when we go to 11 degrees of freedom, which is on the chart, and we go across to 95%, you'll notice it corresponds with a value of 2.201. The numerator of your fraction is the standard deviation, the difference of the standard deviation. So we go to standard deviation. The difference, it says here, is 1.163. And n is 12. We'll type this in your calculator and can calculate the 2 values in your confidence interval. The first value, we get negative 2.754. Then we replace the minus sign with a plus sign in the formula, hit enter, and we get our other value, negative 1.276. We put these numbers in parentheses and separate them with a comma. We finish with our conclusion. We are, choose your confidence level, 95% confident that the mean difference in growth for all pairs of plants is between the 2 numbers we came up with, which is negative 2.754 and negative 1.276. If there's units to include them here. It does mention that we're talking about growth in centimeters, so it's appropriate to include that here. So we've constructed our confidence interval, and there's one more question to answer. It says, based only on the confidence interval in part A, is there sufficient evidence to conclude that there is a significant mean difference in growth of the plants from untreated seeds and the plants from the treated seeds? Justify your conclusion. So they're saying, is there evidence that there is a significant mean difference in growth? Is there a mean difference? Well, if there's a difference, we would expect to have something other than 0 here. If there was no difference in growth, you would expect to get 0 in your answer. No difference in growth means you would get 0. In fact, if you look at this interval, 0 is not even between these 2 numbers. So the answer to this question is based on, is 0 in between these 2 numbers? Because if 0 was, then there'd be a chance that there's really no difference in growth. But this is very clearly saying there is a difference, and we're 95% confident that the average difference is somewhere between these 2 numbers, and 0 isn't here. So there is a difference. So the answer to this question, is there evidence that there's a significant difference in growth? Absolutely. And the rationale is that 0 does not appear in the interval. We will eventually add a little bit more to this answer, but for right now, we basically check to see if 0 is in the solution, and if it's not in that interval, then we say, yeah, there is a significant mean difference in growth. Now you know how to kind of work out a matched pairs t interval, and we will continue adding more intervals over the course of the next week or 2.